All right, here we go. We are solving. Oof, wow, cumulative review 15. Let's have some fun. All right, so I want to solve this exponential equation. The first thing I want to do, I want to try and my goal is to isolate this term with the exponent. Okay, so I need to subtract 1. $39, and then divide by 3. Okay, I am isolating this term here. Okay, so I move the 1 to the other side, and then I recognize that it's 3 times this value. Well, I can't multiply 3 times 7. I can't make this number 21 because this 7 has an exponent attached to it. The rule of operation says I need to do exponents before I take care of multiplication. So I currently have 7 to the 4x minus, 7 to the 4x minus 7 equals 13. All right, now there are 2 methods for doing this. I'm going to show both. Okay, one method, and I believe this is how it was taught in the videos, is like this. Take the ln of 7 to the 4x minus 7 equals the ln of 13. All right. Properties of our logs, if I have an exponent within a log, I can move it down to the front. So I have 4x minus 7 times the ln of 7 equals the ln of 13. Isolate my term with x, so divide both sides by the natural log of 7 divided by the natural log of 7. For x minus 7 equals, and I'm going to leave this in exact form because I don't have my calculator with me. I'll show my answer in exact form and decimal form. Okay. After that, so I want to isolate my x. I'm going to add 7. So these cancel. I get 4x equals ln of 13 over natural log of 7 all plus 7. Then I have to divide by 4. Divide everything by 4. So I get x equals, put that top in parentheses, ln of 13 over ln of 7 plus 7 all over 4 to get x equals 2.08. Now here's the deal. Okay, when I plug this into my calculator, I want to do it in the order as it appears. I want to do ln of natural log of 13 divided by the natural log of 7. Enter. Get that decimal. Add 7 to whatever that decimal is. Press enter. And then divide by 4 at the end. Okay. Be careful with your order when inputting things into your calculator. The last thing you want is to make a calculator error. Now, another method for solving this problem. All right. So I currently have this. This is currently in exponential form. Okay. I can take an equation that's an exponential form and switch it into logarithmic form. If I were to switch it into logarithmic form, the base here is 7, so that remains the base of my log. Equal to 13. What power? Oh, the 4x minus 7 power. Now, a newer calculator, you can do this in your calculator. Older calculator, I have to use a change of base. Log of 13 divided by the log of 7. And then same operations apply. Okay. As in, I'm going to add 7 to that and then divide by 4. But I'll still get the same, I should still get the same answer. Log of 13 divided by log of 7 plus 7 equals 4x. Then divide everything by 4. all over 4. And you should still get 2.08. All right? There's number 10. Wow. All right, number 11. Here's another fun one. All these are fun, really, though. I mean, right? Right? Right, for sure. Okay, so I want to first thing I want to do is I want to condense this, okay? Because I can't solve an equation or a logarithmic equation if it is not condensed. Okay, so I'm going to condense this here. So I have the log base 8 of x, addition means multiplication, times x plus 12 equals 2. All right. Now that I condensed my equation, I want to switch it into exponential form. So my base is 8. My base stays 8. 8 to what power? Oh, the second power equals x times x plus 12. Now this is just a basic, from here on out, it's algebra. Distribute my x. 8 squared is 64. Subtract the 64. Move the 64 to the other side. Now I want to find the factors of 64 that'll add to give, of negative 64, that'll give me 12. So I have x plus 16 and x minus 4. So x equals negative 16 and x equals 4. Now, whenever solving logarithmic equations, I will always want to check for an extraneous solution. Okay? And by doing that, I want to put it back into my original. Well, I have negative 16. I cannot take the log of a negative number. So I toss that one out. My answer is 4. Okay? Here we go. Next one. Let's do it. Again, same type of deal, same start. In order to solve a logarithmic equation, I need to condense that log, even if it is a natural log. So I'm going to rewrite this as the ln, the natural log of 5 over x plus 1. Our second step, after condensing, was to switch it into exponential form. So the base of every natural log is e. So e is my base. E to the third power equals 5 over x plus 1. You can think about this two ways. I can multiply both sides by x plus 1, or I can think about this as being over 1 and cross multiply. Either way, I do e to the third times x plus 1 equals 5. Divide it. I could distribute, but that would make for something messy. Divide both sides by e to the third, and I'm going to leave this in exact form until I show you my answer. And I have x plus 1 equals 5 over e to the third. Okay. Remember, e to the third is an actual number. Okay, that's going to be an actual number. It's going to be like 8 or 9 point something weird. All right. So when I'm solving this, recognize that e is not a variable. It's a number. All right, this is a number. Okay. Last step, to isolate my x, I subtract 1 minus 1, so I get x equals 5 over e to the third minus 1, which gives me an answer about negative 0.75. All right. Either one of those would be acceptable. Okay, just make sure you're reading the directions. All right. Next one. Woo! Limit graphs. Yeah, we definitely need to review this. Okay, let's review this. Here we go. I want to find the limit as x approaches negative 3, and there's this little negative here. So from the left. So here's negative 3. All right. X approaches negative 3 from the left, so this is the left-hand side of my graph. Boom, I hit negative 4. Okay. B, the limit as x approaches negative 1 from the positive, so from the right. Here's -1. As x approaches it from the right, y goes to 0. All right. Next thing I need to do is I need to evaluate the limit as x approaches 0. Okay, so this means that I need both my left-hand limit and my right-hand limit to be the same. Okay, so I need to check my graph from the left side and from the right side. So here is 0, right? From the left-hand side, I approach -1. From the right-hand side, I also approach -1. So the limit as x approaches 0 is -1, since both the left-hand limit and the right-hand limit are the same. Okay. Remember, our left-hand limit and right-hand limit must match in order for the limit to exist. All right. The limit as x goes to infinity, positive infinity. So as x is increasing, what are my y values doing? My y values are also increasing and going off to infinity. Wow, we're cruising. All right. E. Find f of -3. Okay. Remember, f of -3, I'm looking for what is the value of x, or excuse me, what is the value of y when x equals -3. F of -3 has nothing to do with the limits, okay, and everything to do with the value of the function at that particular input. All right. So if I go to -3 for x, I have two things. I have an open circle here, and I have what appears to be a closed circle there. Now, there is not a circle, it just looks like a line. But it's touching, it's making contact here, so I can assume that I can include that point. Well, if there is an open circle, that means x is not going to be that value. All right, there's a hole. If there's a closed circle, that is the value that I look at. So at -3, y has a value of -3 as well. Okay. At -1, now there's supposed to be a hole here. What the heck happened there? There was supposed to be a hole here. All right. I'm not sure if that appears that way on your review packets, but our original thought was to make this a hole. Okay. I'm going to do it two ways. If there was a hole here, all right. If there was a hole here, let's approach it that way. Here's -1. There's a hole there and a hole there. Since there are two holes and no closed dots, then the value of y does not exist. Okay. However, if on your packet you thought this was a closed dot, all right, then I would put 3. Okay. But since we intended for it to be an open circle, I would have put does not exist. Okay. It'll be more clear when we come to our test, so don't really stress out about that if you put 3 there rather than does not exist. But make sure you understand that, all right, when looking at this graph, it's kind of hard to see, but really the difference between these two, here, our function actually touches that value. Here, it stops short. Okay, it stops short, and that is why there is a hole. Had the function continued and touched that value of 3, then we would have had 3 for f. All right, I'm going to stop there and continue the rest of the next video.